All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we just finished up our malaria covnets module. Let's have a look at what we went over today. Now, yesterday, if you recall, the last thing we went over was the max pooling, and today we're going to pick up where we finished off at. So, if we want to build conventional or convolutional layers with TensorFlow, we can make use of the TensorFlow Caress model. Here, we will be looking at the tf.caress.layers.cov2d. These are the arguments for the tf.caress.layers.cov2d that we would pass in. So we have our filters, our kernel size, our strides, our padding, data format, dilation rate, groups, activation, use bias, kernel initializer, glorot uniform, bias initializer, kernel regularization, bias regularization, activity regularization, kernel constraint, and bias constraint. Now we're going to go over the definition of all of these parameters one by one, but I didn't include the filters or the kernel size because those are plenty self-explanatory. Nothing changed from when we went over those during the exercises, so those are pretty much the same. So we're going to start with stride. Now the strides, if you notice with the strides, we have a tuple here, one of one. Now note that the stride comes as a tuple, so if we want a stride of 2, for example, the first number is the height and the second number is the width. So if we wanted to move along the width of the feature map with a stride of 2, we would specify it like this, 1, 2. So that means we still move by one stride up and down, or the height wise, but width wise, we would move with a stride of 2. Also note that if we wanted the stride to be equal for height and width, we would use a single number like 2, for example, to indicate that we want a stride of 2 horizontally and vertically. That means height and width will both have a stride of 2. So it's not what you think. It wouldn't be 2 and 2 if you wanted the height and the width to have a stride of 2. We would just have one single number to represent everything, and that would be a 2 if you wanted to be a stride of 2, or a 1 if you wanted to be a stride of 1, or any other stride number we wanted it to be. If you wanted that number to represent both the width and the height, we would just use one single number to indicate that's the number we wanted all around. But if you wanted to split it up, we would use this here, like a 1 and 2. 1 for the height, or 1 for the height, and 2 for the width. Next, we have our padding. So one of valid or same is case sensitive, so it has to be a lowercase. So valid means no padding. So if the padding equals valid, that means there's no padding. And same results in a padding with zeros evenly to the left, right, top, and bottom. That just means it's going to be padding of zeros all the way around our input. And when the pattern equals same and the stride equals 1, that means the stride equals 1 for the height and the width because you have one single digit there. The output has the same size as the input. We have our data format. It's a string. A channel's last to be by default. That's supposed to be by default. And that's going to be 60 by 60 by 6. So you can see here our channels are last because by default that's how it comes. It comes channels last. If you wanted to specify channels first, it would be like this, channels first, and it would be 6 by 60 by 60, for example. That means the channels come first. Then we have the dilation rate. Let me move down some so I can see my screen. The dilation rate is an integer or tuple list of two integers, specifying the dilation rate to use in convolution. Then we have groups, a positive integer specifying the number of groups in which the input is split along the channel's axis. Then we have activation, is the activation function to be used. If we don't specify the activation, none will be used. Then we have the use bias, is a boolean, whether the layer uses a bias vector or not. Then we have our kernel initializer for the kernel's weights matrix. Then we have our bias initializer, is the initializer for the bias vector. Then we have our kernel regularizer function applied to the kernel's weights matrix. Then we have the bias regularizer, the regularizer function applied to the bias vector. Activity regularizer is a regularizer function applied to the output of the layer. Then we have the kernel constraint. It's a constraint function applied to the kernel matrix. And the bias constraint function applied to the bias vector. Now today was real heavy on the note taking, but we did get out of the malaria covnets module. And we did start a new module today. Well, I didn't start it. I got everything geared up to start tomorrow. So here we will be going over the process of building covnets. That's going to be our next module. We're actually going to go into the process of building covnets. And you can see I have all of my imports already imported over, or what I think I'm going to need. I don't know as of yet. We didn't start the module. I'm assuming that we're going to use everything that we used previously. So I imported all of those imports over to this new module to get everything ready. And then we just have all of the code that we have from the previous module. Again, I'm not sure we're going to use any of this stuff, any of the same data. I just have it queued up just in case we are going to use it, so I can be ready for when we are ready to use it. Yeah, like I said, we did finish up our malaria cogniz module, and we are going to start our malaria building cogniz module tomorrow. And of course, I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.